This book will always talk about valence electrons, and it's just another way to say outer shell electrons. Let's say valence electrons. The most you can have around an atom at any time is 8. It's called an octet rule. So when we build our structures, we're going to make sure that we don't have any more than 8 around any structure. If we have 10 around a structure that we're showing, it's wrong. If you have 12 around one of the atoms in the structure, it's wrong. Okay, if you have 4 around any of them, it's wrong. It's got to be 8. It's got to be 8. The only thing that is the exception is hydrogen. Hydrogen has only 2. You may know why. Because it's the first shell. The first shell can only have 2. All the rest of the nonmetals will have to gain electrons and share electrons to get 8. And they're all going to be, from the second period down, they're all going to have 8 in them. So it's called the octet rule. Everything that bonds, that we're going to look at, everything, no matter what it is that we bond, is going to have 8 electrons in it. Okay? When we show it. Ionics the same way. Ionics is going to have 8 around it as well. It's either going to lose to get 8, or it's going to gain to get 8. But it's always going to have 8. It's called the octet rule. Doesn't matter what the situation is. We're going to introduce you to what's called the electron dot notation. So what's electron dot notation? All we're doing is we're going to make it simpler. Instead of drawing the lines with the arrows, we're going to draw a symbol that represents the element. And then on the outside of that element, we're going to put electron pairs and also lone electrons around that element. And when we do that, it's going to show, it'd be like showing the arrows. It'd be just like showing the arrows in with the lines. But all we're going to do with dots. So this is really easy. All you do is you take your periodic table and you count across a row. Now, how many elements are in a row? There's 8. It goes 2, 8, and 8. And then we got 18. Fourth row. So that 18 includes 10 D elements. Are they valence electrons? No. Do we count them? No. We skip them. They are not they're not valence electrons because they're not outer shell electrons. They only can be outer shell electrons. Now eventually they could be outer shell depending upon if you lose to get there, but to begin with they're not going to be outer shell. So all we do is we count, including the element we're going to in our count, and we count across, and that's how many electrons we show around the symbol. So silicon, how many across? 4. So we go 1. So we go 1, 2, 3, 4. We're done. Has 4 valence electrons. And chlorine, how about chlorine? 7. So I just go clockwise. You don't have to. When we do this, we have these electrons here, and these are called unshared pairs of electrons. So these are going to be unshared pairs of electrons later on we'll talk about. We have one place where we have an opening where we can link in an electron and share it, right here. Anywhere where we have one lone electron, we can share that spot. Okay. It's kind of like having a plug-in like this. Got only one way that can go in, that one spot. Okay, it doesn't have 2 prongs or 3 prongs or 4 prongs that you can use. Okay, it's not like this end. This end has 2 spots that you would need in which to be able to plug this in. Okay, one spot wouldn't work. It has to have 2 spots. So when we get into these bonding, we'll see these places here are already taken up. We just got one place where we can share. All right. Sulfur, you guys go ahead and do sulfur. I have confidence you'll get it right. So go ahead and do sulfur. Count across and then do your dots. pretty easy, huh? Okay. That's the substitute for doing it this way. And you probably much would rather to do sulfur with just the dots like we did than do this every time. Because that's what it represents. Okay? So you don't have to draw that out. We're not doing that anymore. We've already practiced that and looked at that. That's just a long method. Too long of a method to do it. Okay, so then what we're going to do, we're going to give you 6 steps. Follow the steps to begin with. Okay? Be disciplined and follow the steps. Even if you know what you're doing, after doing the first couple, continue to follow the steps. Because if you get to the point where you're getting too big of a hurry and you don't follow the steps, we get to some that are more difficult to do. If you don't follow the steps, you're going to mess up, and then you're going to get those wrong, and there's really no need to do that. Get them wrong. They're not that hard of steps to remember to do. Okay. We're going to do this, put together what we call Lewis dot structures. So they're on paper. They're a two-dimensional view of a model of particular molecule. So we're going to put together molecules with atoms and how they bond. If they got single bonds, double bonds. All we're going to concentrate on today is single bonds. Single bonds become really easy to do. Tomorrow we'll concentrate on multiple bonds, double and triple bonds. Okay? That's what we'll do. So if you would write down steps 1 and 2. Then step 1, go ahead and draw dot notations for S, H, and Br separately. So you got 3 different ones I want you to draw dot notations for. Sulfur, hydrogen, and bromine. You can go ahead and do that under step 2. If you want to show an example of 1 and 2, then you can do that under step 2. I think a lot of you have an excellent opportunity to improve your grade over the next month. You know, we've got about 4 weeks left. And some of you want to kind of finish up strong. This would be a good way to do it. A lot of the stuff we're doing is not real difficult. It's not like the last 2 chapters where you do a lot of theory and that. We're giving you steps to work on and do. Have those down. You do enough of them, you get them memorized really well. We start getting into writing out formulas and writing out names for formulas, and that's just a lot of practice. You can do a lot of practice on your own, and there's one site you can do practice 1,000 of them if you wanted to. I don't think anybody will ever do it, but I mean there's opportunities for you to practice and see what you're doing wrong. And for some of you, you like that extra practice. You like that extra chance to see what you're doing wrong, and you need more than just a few examples to do. You need 8 or 10 maybe to go through and practice. So, and then you can retake those quizzes. So once we started getting into naming and writing formulas, you can start retaking those on your own. We're kind of, in the past I've done it at your own pace, and that we'll just have to see how it goes. But don't think you're stuck at a certain letter grade and you can't improve that letter grade. All right? Keep working hard, and you never know. You might get enough situation where you get some high A's, and labs you get some A's, and that can really help you out. So don't give up hope of if you have a C and you want to get a B, it's still possible. Okay? If you got a 90, 91, you want to get an A, it's still possible. Don't give up hope that you can't get there and do that. So, all right. So do you have them all drawn out? So they should look like sulfur. Is that what you have? How many did you count up?
14.
14. Okay, so you have 14. So what's our next step? What do we need to do? Our next step is we're going to look at our dot structures and we're going to determine which one should be the center atom. In the book it'll say you always want to take the one that has the lowest electronegativity and put it in the center. We don't always want to look at that chart. And there's a better way to look at the center one that you can use instead. You look at the one that has the lowest number of valence electrons, exception would be hydrogen, and that one's your center atom when you draw it in your structure. Okay? So which one has the lowest number of electrons in it? Sulfur. So sulfur is going to be the center one. Then everything else is going to be off the center. It's going to be branched around. I'll show you what that is here in a second. So the center one is going to be sulfur.
Wait, why is sulfur the center one?
Okay, I'll go back. We'll put sulfur in the middle, and then we'll put H and Br around the sides. The reason sulfur is in the middle, it has 6. It needs to pick up 2 to get 8. Hydrogen has 1. It only needs 1 to get the shell of 2. Because it's the only one that does not obey the octet rule. Bromine has 7. It needs 1 to get. So it needs 2. Then it goes in the middle. If you had something up here and it had 5 electrons around it, and it needs 3, that would be your center one now. Yes?
So what if they're like all the same?
If they're all the same,
So like
which is probably not going to be the case, but if they're all the same, then they're just going to be beside one another. A lot of times that would be if you have 2 elements that you're bonding together and they both have like 6 electrons. So then they're just side by side. But you're not going to have, if they are the same, maybe put both of them in the center side by side. So you got 2 center elements. Okay? That's the way you could look at it. Yes, Jared?
Okay, I'm sorry, but on like the 4th period and then down to the 6th period,
Uh-huh.
how do you remember how many electrons go around it?
You count across, but you don't include the D's.
Oh,
So you skip the D's. Skip them. Alright? So any questions about this? Now some students go, can the BR be over on the side? Yeah. So can you have the BR over here? Yeah. Can you have the BR on top? Yes, you can. How about the H? Can it be over there? Yeah, it can be over there. Okay?
Going off to the top right.
I want them at 90 degrees.
Okay.
So 90, 180, 270, 360. Okay? So don't get caught up on their position, because if this was a 3-dimensional object we were looking at and we brought it out, we'd go this way, it'd be on the right. We'd go 90 degrees this way, then it'd be on top. It doesn't really matter on paper how you would put these. Okay? Next step is to show the covalent bonds. So I'm going to go ahead and show you the next step, and then I'll let you write number 3 down. But the next step of the 14 we have counted out now. So that 14 is kind of a way to keep track of all our electrons, all our dots. If we ended up with 16 electrons in our structure, we're wrong. We can't pick up 2 electrons that weren't there. There's 14 electrons involved in either bonding or not bonding around these atoms, and we can't pick up an electron or get rid of electrons in the process. We've got to have exactly 14 when we show our final structure. So the first thing we would do is we would share a pair of electrons between the central atom and the branched atoms, and that shows at least one covalent bond between those two. So when we show pairs of electrons between two symbols, that means it's a shared pair. Bromine's going to share one electron with sulfur, and sulfur's going to share one electron back to bromine. And they share a pair of electrons. Same with hydrogen. Hydrogen's going to share one with sulfur, and sulfur's going to share one with
So
hydrogen.
do they always, like, there's always two?
There's always two, at least two. Now later on, tomorrow, we'll find out there could be 4 in between, and there could be 6 in between.
But right now, we'll always
But
be
from
two.
right now, we automatically, everything has a pair to begin with. Pair of electrons. Everything gets a pair of electrons to begin with. Now that may change when we figure out, what we have left over when we're done, but we won't do any of those today. So step 3 says, let's see, write the symbol for the element that needs the most electrons to get 8 in the center, and surround by the other symbols. I didn't have that one down, did I?
Well, you said determine the center atom.
Right, and I just didn't give you the step.
Isn't
No.
it? So that's basically
Yeah, that's what it says. Long way of saying it. I want to give you detailed steps. Some of you need detailed steps. And I don't blame you. I need detailed steps too. Especially cooking. I get home, I'm supposed to cook something I've never cooked before. You need detailed steps. And then I'll send this out to you for the assignment. Okay? It says to combine this and this. And then it says combine these separately. And then turn the oven on to 350. And I need those detailed steps in cooking. I can't be just... If I was a cook or a baker or a chef by occupation, then I would know, I would be really good at knowing, and I would not have to look at a cookbook all the time. So write the symbol of the element that needs the most electrons to get 8 in the center. And surround by the other symbols. So how many ever that's going to be, you need to surround them. So that's step 3. Step 4 is to pair up the electrons. Okay? So I'll go ahead and have that written out too. Step 4, you're going to have to that's what we did. Place a pair of electrons between the center and each branched atom. So step 4, once you've got your center atom in there, then you just start putting those shared pairs in between. So place a pair of electrons between the center and each branched atom. Now, in our example, that's 4. We're taking 4 from the 14 and doing that. So now we're left with how many? 10. We got 10 electrons left with that we're going to have to show. And step 5 will allow us to maybe start getting some more of those electrons involved. So 4 says, yeah, go ahead and place those pairs in between and make sure you keep track of it. So I've got 4, and so now I've got 10 left I've got to show. Number 5, what you're going to do around the branched atoms, you're going to place unshared pairs of electrons around the branched atoms to get an octet. So every branched atom gets its octet before the center gets its electron. So the center one, don't ever put any electrons off the center other than what you have bonded is in the branched atoms until the very end. There is some students like to give the center atom its 8 before the branched atoms get its 8, and it's going to mess you up. It's going to mess you up big time. So there's a reason and a rhyme and reason why we do it this way, so that when we get to the final structure and we need to manipulate it and change it around, we can do it. But if you do it out of order, you're going to come up with some wrong answers, and that's not going to make you happy. Okay? So place unshared pairs of electrons around the branched atoms to get an octet. So what that means Now hydrogen doesn't get any. I have students that want to give hydrogen 8. It never gets 8. It only gets 2. Poor hydrogen. Never gets anything else. It's 2 and that's it. Everything else gets 8. Now this is not a branched atom. It's the only thing on the outside. So we go ahead and put unshared pairs around the branched atom. We stop when it gets 8. Can't have any more. Can't have any fewer than 8. So now we've used up 6 more. We had 10 left. Now we have 4 left. If we count these all up, we got 10. We got 2 remaining. Anybody have an idea where those 2 pairs go?
On the central.
On the central one. Now, there'll be a time tomorrow where you're not going to have enough to fill the center one with 8. And we'll get to that tomorrow. But you have to go in that sequence. So it has its 8. And then so the last step that we would do, step 6, any electrons left over are placed around the central atom. So anything left over. So the central atom gets the leftovers. Okay? Kind of like your dog at mealtime gets the leftovers. Okay? I'm going to eat everything I can get till I'm full. I'm certainly not going to give the dog something if I'm hungry still. Okay? I'm going to eat it, and if it wants leftovers, anything left over, it's okay, then we'll do that. Yep.
Is there going to be a time where like the branched off electrons won't have all of the
No, there'll never be a time
where they won't have
where the
all?
branched atoms won't have 8. Yeah, there'll never be a time. Now, we might change the look of how many they have later on, but we'll do that tomorrow when we start doing double and triple bonds. So, all right. So, if we go back to that original structure, you can go do it yourself. Put 2 pairs of electrons around sulfur. And so that final structure, when you look at it, if it's complete, everything will have 8 around it. So when you're done drawing a Lewis dot structure, everything must have 8 electrons around it. There cannot be any type of Lewis structure that does not have 8 electrons around it. So 8. We're out of electrons. We've got 7 pair or 14 electrons. We're done. This is called a Lewis dot structure. This is a Lewis dot structure. The other structure I need you to be able to write out is to clean all these dots up that are not involved in bonding or not around the center. So what we want to do is we want to get rid of any valence electrons that are not involved in bonding or not off the center. So anything that's branched atom, it's got extra dots, we want to clean it up. We do what's called the structural formula. Structural formula will look like this. Same, S, H, Br. Then for every pair, I'm going to draw a line between the 2. There's my pairs. They're aligned now. Okay? I already showed you that, right? With the protein structure, we showed lines. Those are single bonds. Then I'm going to show anything off the center that has those pairs. I'm going to show, but I'm not going to show any unshared pairs around the branched atoms. So that cleans it up a little bit. I don't have to show all these dots. They can get really messy if you get more of them. It just becomes. This is much simpler, much cleaner to see and look at.
Wait, why don't we put them around the ERs?
Why don't we do this?
Yeah, why
Later on, we're gonna talk about what kind of shapes these structure will have, and these pairs of electrons are going to be important to know off on the center one.
so
What kind of structure?
Put them on the center.
Just the center, not the branch, because this would be kind of what we call a bent structure. So when we look at it, it's going to be bent, and we're going to have Br and H kind of like something you bend. It's going to be that kind of look structure-wise. All right. So your assignment is to do these 3 for tomorrow. following those 6 steps.
How do you do them with like the, when there's more than?
Okay, so good question. What do we have a subscript? We write that symbol out 3 times. 3 identical hydrogens. If we have, like NH3, we write it out 3 times, or 2 times, or 3
So how
times.
would, like, would that be the central, like, if that's the central atom, like, how would?
Yeah, the one with, usually the one with multiples will never be your central atom. The central atom usually will be the one that has 1 and only 1 atom. So that's some way you can tell the central atom a lot of times as well. You only have 1 of them listed out. If you have multiple ones, hydrogen will never be in the center anyway. It's always branched. Okay, so do those for tomorrow. Remember, your lab is due on Wednesday. That is a summative grade. Do a good job writing up your conclusion on that.